Today I'll be doing the lesson on transpiration practicals, and this is just an explanation of the theories till the apparatus is set up for us by mistake. So the first experiment, we always look at the aim. And I've always taught you to look at the aim so that the aim will tell you, is very important, it tells you what your conclusion must be. So here we look at your aim to determine whether water in the form of water vapor is released during transpiration. So the apparatus you can see is a plant, a leaf of a plant. We use cobalt chloride paper, which is actually blue. And then we use a paper clip. So what we do is, you can see this paper, blue cobalt chloride paper, is attached to the leafy twig to the plant. Okay, so don't think it's broken off. It's attached to the plant. We don't have the whole picture. And after a while, what will happen is transpiration will take place. So you leave this paper on the plant for a long time, the whole day. And you will notice at the top that it's slightly pink, and it turns slightly pink here because blue cobalt chloride paper will turn pink. And at the bottom, it turns more pink. And you should know that at the bottom, there's more stomata. There's more stomata. So blue cobalt chloride paper turns pink after a few minutes, okay? It depends on the conditions, but I would leave it for a long day. The blue to pink, the blue cobalt chloride paper only turns pink in the presence of water. Now, what does that prove? That proves, now let's go back to our aim. Now, aim is to determine whether water in the form of water vapor is released during transpiration. And yes, this does happen. So water in the form of water vapor is released during transpiration. So that is your first experiment. Your second experiment is to demonstrate root pressure. Now, the apparatus that you have is the glass tubing, a rubber tube, water, and you have obviously the sap from the root. So what happens is you have a pot plant with just the root, and then you have the rubber tubing put over the root, and then you have the glass tubing, and then you water the plant. So we water the plant, and we know what's going to happen eventually is the root pressure will cause water to move up, and you measure the level of the water initially, or the rubber tubing, and then you will measure every day. You'll see the level of the water will increase, and water is being pushed up by root pressure. Your precaution is you must put oil on top of the water. Okay, you always start off with a little bit of water. You always put oil because you don't want the water to evaporate. So the oil prevents evaporation, and the soil must be kept moist. If it's kept moist, and obviously there will be water to be pushed up, so we can ensure root pressure does take place. The next one we use is these glass tubes. There's different sizes of glass tubes, and we use colored water. Usually we use red color water. And you will notice the narrower tube. The narrowest tube, the water moves up the glass tube, up the narrowest tube, the highest. Okay, highest in the narrowest, and obviously in the widest, the least. And that we know is to demonstrate capillarity, which we know it's because of the adhesive and coercive forces. That capillarity pushes the water up the thin glass tube. The next experiment is to demonstrate transpiration. And here we have two bell jars, okay, set up. We have beakers. We have the blue cobalt chloride paper here. And then we have a leafy twig, and then we have a twig without leaves. So this is obviously your control, and this is obviously your experiment, because you want to see if transpiration is taking place. So you need the leaves, and here you took away the leaves. So that's your control. You have to seal this beaker, this glass bell jar, with Vaseline. Everywhere it must be sealed with Vaseline. Everywhere it must be sealed properly with Vaseline. You don't want the moisture from the atmosphere to enter and affect your result, and you don't want this moisture from the atmosphere to leave, because you want to know that whatever the result is, it's from transpiration. So what you will notice here is you can see that there's blue droplets here. So firstly, that blue droplets collect because of transpiration, right, that occurred because of the leaves. And then this blue cobalt chloride paper will turn pink, proving that this water is present, water is given off, or transpiration has taken place. Okay, so that is now the result, and your conclusion will be that transpiration mainly does occur through the leaves. Precautions: you must seal the leaf scars. So on the leaves here, on the twigs here, you must seal it with Vaseline because you don't want any other moisture to be released. You want to know that this water that's been released is from transpiration. And again, I told you about the bell jar being released with Vaseline. Okay, so the next experiment, we don't ever set up the next experiment. We want to demonstrate the strength of transpiration pool, the cohesive strength of transpiration. We never set it up because mercury is dangerous, so we don't use it. And mercury is one of the most densest metals. So I have seen this experiment. It has been set up for me at school. And you just use a little twig and you put mercury in here. And the transpiration pool is so strong that it pulls up the most densest metal. It pulls it up. That's how strong transpiration pool is. Okay, so that is the precaution. We'll talk about the precautions for the next experiment. So yes, transpiration pool is very strong that it pulls up the mercury up the sulfano. The next experiment is extremely, extremely important. We want to measure the rate. The rate is how fast or how slow transpiration occurs in different environmental conditions. The instrument used to measure the rate of transpiration is called a potometer. Please don't say potato meter, it's a pot-o-meter. If you need to spell it, pot-o-meter. You can say it like that as long as you know how to spell. So here what you have is, you have your beaker here filled with water, you have your glass tube, right? And you have your burette with water, and then you have more water. And there you have your leafy twig. Now what happens is, you want to form a bubble, so you lift up this glass tube, so this glass tube lifts up and air goes inside. And that's going to cause a bubble to form, and then you can see your bubble here. You can see a bubble here. And then depending on whatever the plant is exposed to, whatever environmental condition the plant is exposed to, that determines the rate of the movement of the bubble. And if you want to, now, there's usually another tap here. If you want to move the bubble backwards, you can move it back by opening more water. Water will go in and push the bubble downwards. Now, let's talk about the environmental factors that are going to affect the rate of transpiration. So now we look at the sun. And we know it's high light intensity or high temperature. With high temperature, the bubble is going to move faster because we know high temperature and high light intensity increases the rate of transpiration. You can even put a heater. It doesn't have to be in the sun. You can put a heater. The next one is if you put a fan. Sorry about that. I know you can see all my changes I'm making. If I put a fan here, oh, excuse how I'm drawing my fan. If you put a fan and you get wind, we know high wind increases the rate of transpiration, so the bubble is going to move faster. And the last one is humidity. Now, if I take a plastic bag, put it around the twig, and there's a few droplets of water inside, you know that there's high humidity. High humidity, you know, slows down the rate of transpiration, and so the bubble will move slowly. So if I ask you the environmental factors, if you remember our previous lesson, it must be high temperature, high light intensity, high humidity, high wind. So if you've seen wind, Bubble moves faster, high light, bubble moves faster, high temperature, bubble moves faster, and it is obviously the high humidity that the bubble moves slower. Now, so here's the 4 environmental factors. Please write there: high temperature, moves faster, low humidity, high wind, high light. Please fix your notes up. Okay. What will happen if a plastic bag? Yes, the plastic will move slower because if you remember, there's your leaf. There's high amount of water in the leaf, and around the plant there's still high amount of water. Right? There's no gradient, so it decreases the rate of transpiration. We did this already. Now, there are a few. You're still going to see the reservoir, and the reservoir has a little tap, and that's what actually moves the bubble back to position. I want to talk to you about the precautions, and the precautions are very, very important. And you must be able to state a precaution and explain a precaution. So the first one is when you're cutting the twig. You cut the twig. Okay, just going to do it properly. You cut the twig underwater and at an angle. At an angle, so it does increase the surface area, so more water is absorbed. Underwater is because you are working with water, and so you're working with water, and you don't want any air to enter because the air will block the xylem. Okay. Obviously, you need a actively growing leafy twig because you want a great faster rate of transpiration. Every apparatus that you work with must be tightly sealed with Vaseline. Everywhere it must be sealed with Vaseline. The waters must be covered with oil so to prevent evaporation. Because you want to know the water that's been lost is from transpiration and not evaporation. And airtight, again, you don't want the water to be lost and you don't want moisture from the outside to affect your results. Rubber stopper must be filled tightly, the same reason. You must use a sharp scissors when you're cutting the twig underwater. Sharp scissors because you don't want to damage the xylem. If you damage the xylem, then water won't be transported and you won't see the effects of transpiration. So please make sure you explain, you can state the precautions and you can explain the reason why. And there, ladies, is the explanation for your transpiration practicals. Thank you.